Welcome to the MDB YouTube channel. If you want to support us and learn more about our club, please follow the link in the description and be sure to subscribe to receive more updates about when we release videos. Enjoy! Welcome to the video today. I was interested by the idea of making a kind of like a gamepad, like a Xbox controller for this club I'm in. And so as I've been discovering how to create something like that kind of from scratch, I came across a joystick. And I got interested about how that was working. And so what is a joystick? So we have, as everyone knows, we have our joystick, right? It's connected to this pad. And you can take it right, up, left, down, or kind of any direction in between. You can go this way, that way. So basically, you can move it any direction. And you can break up this movement into a position on a plane. So if you imagine your joystick is at the center here, you can go ahead and you can push it here. Say you want to push it up to the up and to the right. And from that, you can take a position on your X coordinate and your Y coordinate, and that can translate to something you can send back to whatever you're trying to control. So that's generally like what a joystick is and a lot of joysticks will also have, if you look here at the side view, so this is the top view, this will be the side view of a joystick. It'll also be able to press down on a button. So that's kind of a rough schematic for how that looks. And you press down and this thing clicks. So you get a press and it clicks down. And what that does is, you can toggle. If you've played any video games, you might toggle sprinting, running faster, or any other number of motions you can do. For instance, you're controlling a robot with a joystick. Maybe you want to switch between speed modes. You can use this kind of button as a toggle. And that is a simple, right? You either toggle, it's either yes or no. All right, or you can write that as true, false in a Boolean, or 1, 0. Okay. So now that we've talked about kind of what a joystick is, right? How does it work, right? From a circuit level, how does a joystick work? And so you can see, right, from the earlier part, we can break down our joystick into X and Y movement. And by moving it, you're actually changing a potentiometer. So you move this is generally what by moving your joystick along the X direction, you're going to change the voltage that passes through your joystick from a circuit level. And depends in a potentiometer, the way that works is how much you rotate it is how much you change your voltage. So the same principle applies here. You can rotate your joystick left, right, up, and down. And in combination, you can break that apart into its X and Y components. So you see here, you can kind of draw that as you have an X input voltage, And then you have this that's a potentiometer. This leads to a voltage drop. So X is going to be bigger than X out. So depending on where you put it, your potentiometer, right? This could either have a very small effect, so X out is basically equal to X, or you can have a very high resistance, right? You put it to one and you put it to the other, and that might mean that your X out is almost equal to 0. So that's kind of the principle that applies. So that means you can take your X values and you can say they go between a value of 0 and 5 volts. And then the same exact for Y. So this is important. You can map your X value to a continuous line that kind of varies between 0 to 5 volts. And the same thing happens for Y. And then for your button, you basically just a switch. So you say here, you say you have we'll call this a B for button. You have a switch and then B out. And when the switch is open, obviously you have 0 volts coming through that. So, right, if it's open, you don't press it, so you have 0 volts. So it's either B, you can write it as a piecewise function, to 0 if, we'll call this a switch open, or it's equal to B. So B out is equal to switch is closed. Okay, so that's kind of like a general level of how it works. And the next thing you want to figure out is how can you take these voltage values and get them into a way that a computer can know, right? How do you say a voltage is equal to this number, right? Because computers work off of numbers. So this brings up the problem between analog and digital, because as we discussed in the last part, right, you have your X value for your joystick. That can go between anywhere between 0 and 5 volts. And it depends on the resistance. So you can draw it like a kind of straight line. And this means that X could be any value. X could be 0.0000026 yada 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 volts. But a computer, and we call this digital, right? So what this X value is going to be in analog, right? This kind of a real number. It doesn't have to be a distinct value. But when you go to computers and these digital signals, you want them to be in distinct integers or natural numbers, if we're talking about. Depends what you take. But usually you want to talk about any number 0, 1, 2, 3, right? These distinct numbers. So we can take this here and we can say, how do we get from this analog to a digital? And that's the main question that you want to answer, because on your computer side right here, you want to be you want it to be equal to something like 0, 1, all the way. It could go as high as you want. So that's kind of the problem that's presented. But there are a lot of people have thought about this before, and we wouldn't be talking over YouTube if they hadn't already solved this problem. But the solution is to convert analog to digital, right? If you can figure out some way with some circuitry, maybe some processing to convert them, it'd be pretty easy. For these joystick values, you want to convert these analog continuous signals to these distinct digital signals. So you need an analog to digital converter. And first, before we can talk about how an analog to digital converter works, you need to talk about how a digital to analog converter works. Okay, so here's how a digital to analog converter works. So say you have this number in digital logic, zeros and ones. So you say 1 0 1 1 1 0, etc. And you want to take this and you want to say, okay, how can I get to a analog signal? How can I get to a voltage from these zeros and ones? Well, you can say, let me look at each of these bits. And you know that in base 2, each bit is going to have a different weight. So you can basically flip a switch for each bit on and off, given if it's a 0 and a 1. And maybe that'll help you. And there's some more circuitry involved, and it's a little out of scope for this video, but basically, what if you can add all those together, right? This is exactly how you convert right from binary to base 10, right? You can pretty easily convert if you can figure out how to kind of scale them and add them together, right? Your most significant bit here, which is going to be this one, which happens to be in 2 to the 5, right? If you can somehow scale it so that this one is, kind of twice as much as the next one, and etc. And that works out. You can kind of, for each bit, you can present that as an input. You can say, this can either be on or off. On or off. And for each of these, you can say it's on or off. And they feed, and somehow they add together. And out of it, you get an analog signal. And it's that simple. It's the circuitry and the analysis is a little more complicated than just this, but you work with a series of resistors that are all combined here, and that works out so that you have your most significant bit up front and your least significant bit out back. And you can see the general concept behind resistors is you drop your voltage level when you when you go through a resistor. So you can tell just here from the diagram, as if you turn on this least significant bit, it's going to get, right, it's going to start off here, it's going to drop over this resistor, drop and keep dropping, and going to be very less. Then if you send the same voltage through here, it's going to start here, right, most significant, it'll start here, and it won't, it might drop a little bit from this other resistor, but it'll come here, and so you have your most significant bit contributing a lot more than your least significant bit, which is exactly what would happen like in our other calculations. So that's your DAC converter. This leads us to our discussion of a analog to digital converter, or in short, ADC. And there are a few different methods for calculating this conversion, but the general idea is this one format called SAR. SAR, ADC, stands for successive approximation. So you can kind of infer from the name what this will look like, and we'll see it. And it uses a digital to analog converter in, which is why we covered that first. So first, let's draw a kind of a sample block diagram of a circuit you would have. You would have this analog signal. We'll call this V analog. And that will come in here. and you want to say, what can I compare? Can I look at this? Can I contrast anything to see what will look like a digital signal that if I run it through a digital to analog converter will look a lot like this analog signal. So you want to try to compare the values. So we have this piece called a comparator, which basically takes two values and it'll say basically yes or no, right? It'll say if plus is greater than minus, it'll say yes, and then if minus is greater than plus, it'll say no. So then you're gonna get kind of your yes and no out of here. And in reality, your circuits are gonna work with, you'll have a supply voltage and it'll tell you differently. But for the sake of demonstration, we'll just say yes or no. And so how this works is you have your analog signal and you want to compare to it, so you say, let me try out a bunch of bit values. So we'll look at 6 bits like we looked at in our digital to analog converter, and we'll say, okay, let's try doing 1 0 0 0 0 0. And if that's bigger than your analog signal, right? You get an analog signal out of your digital analog converter. If that's bigger, you know that this first most significant bit can't be a part of the digital signal that corresponds to this analog signal. So you say, if you get a yes, then you keep it. If you get a no, then you have to say, I can't do this. So you have to set this to 0. You say either yes or no. Right? You convert it to you keep going down this path for each of the bit, and you flip them on. If you flip it on and you find that the signal's less than the analog signal you're comparing to, you say, okay, we'll keep that in. And so then the next one you turn on, you would add it together. So say this bit is, you go along and you say this one is in here. So when you compare this one to it, you would say, okay, you're going to add 8 plus 4. So you would be comparing the value of 12 to your V analog signal. Anyway, so you keep going, and once you're done, this will leave you with a string of bits that might look something like this. And in this case, that is your digital signal that compares to 13. So if your V analog is, say, 13.1, 13.3, you know, the closest binary you're going to get is 13. And so that's how it works. To go back to our joystick, we'll look at simply just the X direction, and we know we can break it up component-wise and then put them back together. So you look at your X direction, you say, okay, I'm going to go left or right and whatever. And that's going to leave you with a voltage signal. That's going to give you a V analog. Right? That's going to give you a V analog signal. And you want to take this signal and you want to say, okay, how can my computer read this? So you're going to pass it through a analog to digital converter, and that will give you a series of zeros and ones that corresponds to your analog signal. From that, your computer can say, okay, your X position is, right, in the example, say you can only handle a certain given number, you can say your X position is 13. And this is relative to the max binary value, you could say. So your X position is 13 out of a possible of for if you have 6 bits, your max would be 2 to the 6 plus 2 to 6 minus 1, which is 123. So you would say that's 13 out of 123. If you're looking at this one, which is equal to 13, compared to the max value that it could be, which is 123. So that's basically how your joystick works. And the button is much more simple because it's either on or off. And that translates exactly to binary. You have either 0 or 1, and you can tell if the button is pressed or is not from that. Thank you for watching. I hope you've learned some important things about kind of digital logic and circuits and how things work together to create the electronics that we love to use so much every day.